Hello students, this is question number 13th of IOQM 2025 and 26. And the question says consider a 5-digit positive number of the form of AB, C, AB that is divisible by a 2-digit number AB but not divisible by 13. Then what is the largest possible sum of digits such that of such number? Okay, so largest possible sum of digits we need to find for such number. Now, first of all, the 5-digit number which we are talking about ABC AB. Now, this is going to give us a 0 when divided by AB. So I can write that ABC AB is going to be congruent with 0 mod AB. Now this ABC AB, I can write it as this 10 to the power 3 AB plus C plus uh, AB over here 10 square. This is going to give a 0 congruence modulo AB. And this indirectly, if I'm going to see, so this is divisible by AB, this is divisible by AB, so I can write this is 100C modulo AB. Now, I can see from here that what can be AB. Now, AB can be either 0 or either it can be 100 or either it can be 200 or it can reach till 900. So, AB as a number, it can be any of these. So, in that case, if I'm going to see, first of all, 1000 times of AB plus 100 times of C plus AB. This is giving not congruence with 0 modulo 13. So if it is not congruent with 0 modulo 13, then we can see these two will get deducted. So we can see that 100C is not going to congruence 0 with mod 13. Means C cannot be 0 from here. And if C cannot be equal to 0, then the first case which we have assumed, this is going to be neglected. Now AB max I want. So AB max will be equal to when C is going to be equal to 900 and C is going to be equal to 900, or AB max will be when C is equal to 9. So if C is going to be equal to 9, in that case, the value of C is going to be equal to 900 divided by AB. Now, what can be AB over here? So for this to AB to be maximum, then we can see that AB can take the values as 10, 12, 15, 18, and so on till 75 and 90. Now, AB maximum or the A plus will be maximum in the case if I'm going to take this AB in order of 75. So this AB as an order is going to be equal to 75 and C value is 9 already. So the number n which we were aiming for, that will be 75975, and the sum of the digits over here, that is going to be equal to 33, and hence 33 has to be the final answer, and the same has been mentioned by IOQM final answer key as well.